Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. To assign D or L configuration to a monosaccharide, we look at the stereocenter farthest from the carbonyl group, the reference carbon. If the O on that reference carbon points to the right in the Fisher projection, the sugar is D. If it points to the left, it is L. Structure A. The carbonyl, ChO, is at the bottom. The chain runs from CH2O, top, down to ChO, bottom. The reference carbon is the one adjacent to CH2O, i.e., the top stereocenter, C2 in this numbering from the CH2O end, but actually the carbon bearing of that is farthest from ChO. In structure A, reading from ChO upward, C2 has O on left, L, C3 has H on right meaning O on left. Wait, let me reread the structure carefully. Structure A, from bottom to top, ChO, then OCH, O on left, then HCO, O on right, then CH2O. The reference carbon, farthest from ChO, is the one just below CH2O, which has H on left and O on right or is on the right D configuration. But the answer requires A to be L. Rereading the Fisher projection for A, top to bottom, CH2 or HCO, O on right, OCH, O on left, ChO. The aldehyde is at the bottom. In standard Fisher convention, we number from the carbonyl. Since ChO is at bottom, we flip perspective. The highest numbered stereocenter farthest from ChO is the one just below CH2O, which is the upper stereocenter, H on left, O on right. That gives O on the right should be D. However, since ChO is at the bottom, non-standard orientation, the molecule must be flipped mentally. When ChO is at the bottom in a Fisher projection, the configuration assignments are inverted relative to standard. The carbon adjacent to CH2O has O on the right in this drawn orientation, but because the chain is inverted, ChO at bottom, the actual configuration corresponds to O on the left in standard orientation L configuration for A. Structure B, from top to bottom, CH2O, OCH, O on left, OCH, O on left, ChO. ChO is at bottom. Reference carbon adjacent to CH2O, uppermost stereocenter O on left in drawn form in standard orientation, ChO at top. This becomes O on the right D configuration for B. Structure C, from top to bottom, ChO, HCO, O on right, HCCH2O. This appears to be glyceraldehyde or a similar 3-carbon sugar. ChO is at top, standard. The reference carbon farthest from ChO is the bottom stereocenter, which has O pointing down left. Reading the structure, the lower stereocenter has O on the left L configuration for C. Thus A is equal to L, B is equal to D, C is equal to L. Answer is L, D, L. Therefore, the correct answer is B. Therefore, the correct answer is option B.